to the next point. We should ensure that whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Hello and welcome once again to the Kaduna State Ministry of Education e-learning platform. Today we'll be taking another episode of our interesting subject, chemistry. My name is Mr. Philip Mamman. I'll be taking you through the introduction of chemistry. People wonder why we study chemistry. Today you'll be looking at some of these reasons that make chemistry a very important subject. As we live on Earth or in the universe, we want to know what is happening around us. And that's some of the issues that raise the curiosity of scientists to go into chemistry. Man or human being has shown interest in the world around him. This world includes physical environment, for example, the soil, rock, the air, atmosphere, and biological environment, that is, other living things around them. The attempt of man to investigate the world around him led to the science of chemistry. Like I said, the attempt by man to study things that happens around him led to the study of chemistry. For instance, man wants to find out why an air conditioner brings in cold breeze or cold air, or why petrol or kerosene burn when you put a match or a flame close to it, and so on and so forth. So these are some of the reasons why man ventured into the study of chemistry. Now, what is chemistry itself as a subject? Now, chemistry is a branch of science that studies the properties of matter in terms of composition. Composition means what matter is made up of. For instance, water. Water is made up of hydrogen and oxygen. Air is made up of oxygen, carbon dioxide, rare gases, water vapor, and so on and so forth. So that is what composition is. So chemistry tries to study the properties of matter in terms of composition. Also, it tries to study the properties of matter in terms of structure. Structure means how the molecules or the elements that makes up this matter, how they are arranged. Are they arranged linearly in case of carbon dioxide, or tetrahedrally in terms of methane, or they are arranged trigonally in terms of ammonia, or it has a V shape in terms of water molecule. Now, it also studies the composition or transformation. The transformation means changing from one particular state to another. For instance, if you put water in the refrigerator, it solidifies to give you ice. If you bring it out, it melts to give you water. And when you heat the water, it vaporizes into gas. So there is transformation in this matter. Then, of course, there is interaction, how matter interacts with one another. For instance, if you bring cement and add water and leave it over sometimes, it becomes very hard. That's the interaction between water and cement, and so many other issues. Then, energy implication of chemical changes. Now, sometimes when substances are reacted together, they either produce heat in form of sensation. For instance, I'm sure oftentimes you have used detergent to wash your clothes. If you put the detergent on your palm and introduce small quantity of water, you feel a hot sensation on that palm. That is because of the interaction between the detergent and water, and that's the energy implication. In chemistry, these reactions are into two: exothermic, meaning giving out of heat energy, or endothermic, meaning absorption of heat energy. You have seen this in our previous lessons, what an endothermic reaction is, and also what an exothermic reaction is. Now, having known what chemistry is, we have been talking about matter. What actually is matter? In chemistry, we say matter is anything which has mass and occupies space. When anything that has mass and occupies space is referred to as matter. It then means that matter can be water, it can be soap, it can be toothpaste, it can be pepper, it can be air, it can be so many other things. Look around you, you will see matter. Smoke is matter, bricks is matter, raindrops is matter, helium in a balloon is matter, ice cube is matter, cloud is matter, steam, tea, dog, river, oxygen, name them. There are a lot of things that are around you that we refer to as matter, provided they occupy space and have weight. Somebody will say air is not matter, that when you remove everything in a room, you say the room is empty. But in science, we don't see the room to be empty because it contains air. Now, how does air occupy space? You can do a very small experiment in your room. Get a balloon or a leather bag. Bring it close to your mouth and inflate it. Once you are inflating it, it increases in size. It means that that balloon actually air occupies space in the balloon. And if you put that balloon on a weighing balance, you will definitely know that it has changed in mass from the initial mass it has earlier. So air also is matter because it occupies space and has mass. Now, having mentioned that, why is chemistry seen as science? Chemistry as science. Now, when we study chemistry, we try to find out about the materials around us. The earth and all the things on the earth are made up of chemical substances. Everything on earth, just name them. Your clothing, your body, your perfume, your body cream, and so on. They are all made up of chemical elements. And that is why we study them in chemistry. Everything that is all form of matter are made up of chemical substances. A chemist is a scientist who carries out experiments to discover the property of matter or materials. Now, when you look around you, you find out that everything is made up of a particular element. I'll give you, for instance, when you burn wood, you get charcoal. When you burn bones, you get charcoal. When you burn sugarcane, you get charcoal. It then means that all these things that gives you charcoal as a product contain the same element. In chemistry, we say they are made up of carbon. That carbon is the charcoal that you see. So every substance is made up of a chemical element. Now, in that regards, we'll be looking at what is an experiment. We talked about experiment. Now, oftentimes we carry out experiment in the laboratory. So in the laboratory, you carry out an activity. So we say an experiment is an activity in which a scientist determines the effect of one variable or condition on a substance while controlling the other variable, preventing other variables which may affect the substance from affecting it. We perform experiments to investigate the pattern of behavior or matter. Now, if you want to investigate a certain material, you take it to the laboratory, you carry out an experiment. And this experiment is trying to find out a particular pattern of behavior of this material. So you have to measure the conditions that will influence the outcome of your experiment and prevent them from happening. I will give you, for instance, if you want to take experiment on how long it takes you to cook rice, first of all, you will get everything that you need to cook this rice with, the flame. Now, if you know that if you open the windows, it will interfere with the flow of flame, you have to close the window so that it will not interfere with the flow of the flame, and it will give you the time that you need for this experiment to be concluded. So experiment has variables. There are conditions you vary, and there are conditions that you keep constant. And that is what an experiment is. It's very, very important in sciences. So I will take you to the next, what we call scientific method. In this experiment, there is a way scientists go about investigation. And this way is called scientific method. We say scientific method is a systematic process which scientists use in the study and solution of scientific problems. Oftentimes, there are scientific problems, and the way scientists go about to give solution to this scientific problem is called scientific method. Scientific discovery comes as a result of the use of the scientific method to investigate the observation made about matter using the sense organ of human body, and sometimes with the aid of instrument. Now, this scientific method, like I said earlier on, is a coordinated way of investigating certain things that you want to find out about a matter or about a material. And this we use our body sense organs. Like, for instance, you want to find out whether a substance is hot or cold. You do it by feeling, by touching. Or you want to test whether it is bitter, it is sweet. You test with your tongue. And if you want to see how it behaves, you can use your naked eyes to look at it. Oftentimes, there are certain things that your sense organs cannot test. And that's why when you bring instrument, for instance, you want to test the mass of a substance. You cannot just put it on your palm and actualize the mass, except by the use of a specified weighing balance or instrument. So you can use the sense organs to investigate, as well as you can use other specialized instruments to carry out this investigation. Now, how do we go about this scientific method? In this scientific method involves processes. Scientific method involves processes, and these processes start with observation. We said scientists observe pattern in the environment. This observation caused the scientists to start asking questions. Scientists observe patterns about a matter, and this pattern caused the scientists to start asking questions. For instance, from the observation of abnormal behavior of human beings of recent, it was discovered that they were carrying a virus called coronavirus. How did we get coronavirus? It was because it was observed that the pattern of these humans was changing from what it used to be. And then they discovered that there was a virus in them, and this virus was called coronavirus. So that's why we say scientists observe patterns in the environment. This observation caused the scientists to start asking questions. For instance, today there is irregular rainfall, or there is too much of rainfall, or there is too much of temperature from the sun. Then scientists begin to find out, oh, this was not like this before. How come these things are changing? And when they find out, it becomes a problem to them. And when looking for a solution to that problem is what we refer to as scientific method. Remember, I said that this observation caused the scientists to start asking questions. These questions are problems which challenge the scientists to find out more about matter. Now, this quest to know more about matter as a result of this problem is what we are talking about. The scientist comes out with a tentative explanation. When we observe over time, scientists come out with a tentative explanation of what he thinks is happening to a particular matter or is happening to the environment. Now, this tentative explanation or intelligent guess is called hypothesis. The next word there is hypothesis. Remember, first of all, the scientist will observe. After observing with his sensory organs or using an instrument, the next thing is an intelligent guess. And this intelligent guess is called hypothesis. I'll give you, for instance, if you have a freezer in your house and you decide to keep biscuits on top of that freezer, and after some times you came back and realized that the biscuit is no longer on that freezer, you will start suspecting that somebody must have taken the biscuit. Now, from that, you now become curious. Who took the biscuit? I am the one that kept the biscuit. If, for instance, you have two children in your house, one is 2 years old and the other is 15 years old, you know that by height, the 2 years old is disadvantaged to pick the biscuits from the refrigerator, or the 15 years old has high advantage to pick the biscuit from the refrigerator. You can conclude that, or you can give an intelligent guess that the biscuit was taken by the 15 years old child because of his height. But that guess is might not actually be true. How do you know that it's not true? You have to carry out an observation. And when you carry out this observation, you monitor and see who actually took the biscuit. It might maybe be a rat in your house that displays the biscuit from where you kept it. So you can see that sometimes the intelligent guess can be true. It cannot be true in other cases. And that's why we say the scientists come out with a tentative explanation. Why is it tentative? Until you carry out an experiment before you can confirm that this intelligent guess is actually true or false. Now we move to the next one after hypothesis. The hypothesis is tested. If it is not correct, it is then being modified. Now from the explanation I gave you, if you discover that it was not your tall son that took the biscuit, it was a rat that displaced the biscuit, you can now modify your thought, or you can modify your hypothesis. In such cases, if eventually what you thought happened to the biscuit actually happened to it, it becomes that your hypothesis was correct. So we say then the hypothesis is tested. If it is not correct, it is then being modified or discarded for a new one. But if it is correct, the result is then published and the experiment is repeated severally. Now, even at that point, when your experiment is seen to be correct, your hypothesis is seen to be correct, it has to undergo further experimentation to see whether it can stand the test of time. And we say repeated severally by other scientists. If the result is the same in agreement, and the times it becomes a scientific theory. If that experiment is carried out by someone else, other scientists, and it gives the same hypothesis or the same result that you have given earlier, then the result becomes a scientific theory. This scientific theory will continue to work over a long period of time. If this experiment is carried out over a long period of time, and this hypothesis was upheld, it becomes a principle or a law. I'd like to use a chart flow to actually explain to you what these scientific methods means. You can see that in scientific method, the first thing is to carry out observation. And when you carry out observation, like I said earlier on, you raise questions. These questions become scientific problems. Now, this scientific problem, you try to describe this scientific problem, that and profile possible solution, it becomes a hypothesis. So the scientific problem is a hypothesis. Now you have put the possible solution of the hypothesis is what you are looking for. And you can only do that by carrying out experimentation. This experimentation is to test the hypothesis. Remember I said that this hypothesis can be true, that is upheld. But if this hypothesis is not proven by the experiment, it can be rejected or it can be modified. And when it is modified, it will go back to the test or experimentation again to confirm that it will stand the test of time. Now, when this experimentation is positive, the hypothesis will be reproducible with other variables, and further experimentation will be carried out. Then it becomes a theory, and the theory becomes constant over a long period of time. It becomes a principle or a law. This is how the scientific method can be shown using a flow chart of the scientific method. My wonderful students, I have told you that this scientific method are experimented in the laboratory. Of course, in this laboratory, there are equipment or apparatus that are put into use. What is a laboratory? A laboratory is a designated place, a room or an environment whereby experimentation takes place. Now, these rooms have apparatus that are specialized or specifically designed to carry out certain purposes. And we'll be looking at some of the common apparatus that you'll be seeing in the laboratory. One of them is called a desiccator. A desiccator is an apparatus that is used for drying in the laboratory. Now you can see that it has a cover, and the cover is connected to the main body of the desiccator. Now the cover here is meant to be airtight. Now how do you make it airtight? By applying lubricants so that it will not allow the passage of air and moisture. And at the base here there is a drying agent. This drying agent absorbs the moisture in what substance you are trying to dry, and eventually the substance becomes dry. Ordinarily it can be done. Sometimes it is put in an oven to accelerate the drying conditions. Now, what are drying agents? Drying agents are substances that absorb moisture. Example is silica gel. I tell you, oftentimes when you buy a leather shoe or a leather handbag, as the case might be, you find out that there are some substances inside an envelope. The essence of that substance inside the envelope is to serve as a drying agent, because moisture can affect the material, which is either in leather form or a skin form, as the case might be. So this is a desiccator. Very, very important apparatus. Is used for drying in the laboratory. Then we have beakers. Beakers are used to carry solution. They are of different sizes. Then we have reagent bottle. And you can see that we have two major types of reagent bottles. We have the colorless reagent bottle, and we have the amber-colored reagent bottle. The amber-colored reagent bottle is used to control the intensity of light that enters into the reagent, because some reagents are photochemical. The chemical reaction takes place in those reagents. We have the test tubes, the test tube rack, the Bunsen burner, measuring cylinder, the weighing balance, the dropping pipette, your retort stands, your funnels. We have the Bucknell funnel and the ordinary funnel. We have the round bottom flasks, the flat bottom flasks, and some certain safety apparatus that use it in the lab, like goggle, your lab coat, and so on and so forth. Having said this much, sometimes you want to find out the weight of a substance in the laboratory. You use a weighing balance. This is a specialized scale used for weighing to find out the accurate mass of a small object or substance. There are many types of weighing balance that we use for chemicals, like the top loading and the electronic balance. Their degree of accuracy or the size of the material help us to know which kind of weighing balance to use, as the case might be. We have the Liebig condenser, which is used to convert a gas to liquid during distillation. We have the standard volumetric flask, which is used to prepare a standard solution. Remember, in my previous class, I've told you that a standard solution is a solution of known concentration. My wonderful students, as we round up our lessons today, I would like us to look into our assignments. These are some of the things that you go into to see whether you have actually learned from the lesson. And you can use resource material to give us answers for this assignment. My assignment says, define the following. 1, chemistry. 2, scientific method. 3, experiments. Number 2 says, using a flow chart, describe scientific method. Then number 2I says, list 5 common laboratory apparatus and state their uses. I'll take that once again. Number 1 says, define the following. Number 1I, chemistry. 1II, scientific method. 1II, experiment. Number 2 say, using a flow chart, describe scientific method. And 2I says, list 5 common laboratory apparatus and state their uses. My wonderful learners, viewers, and listeners at home, I hope you have had a swell time listening to my lesson today. And for your references, you can always go to these materials, Understanding Chemistry by Godwin Ojokuku. Number 2 is New School Chemistry by Oshao Yao Ababio. And of course, you can always lay your hand on Stand Chemistry Textbook for SS1 by Science Teachers Association of Nigeria. I've had a swell time with you in this lesson. I hope to do it some other time. But as usual, if you have any question you want to raise with us, you can always call our numbers. My name is Philip Mamman. My number is 080-2659-8861. Again, Philip Mamman, 080-2659-8861. 8861. Stay safe, keep learning. Corona is real. Have a wonderful day.